Hello, today we are going to perform peptide array synthesis on a membrane using the multi-pep2 instrument. You can make hundreds of unique peptides in a very short amount of time, and it's way more efficient than hand coupling synthesis. The first thing that you need is to have the sequence of the peptides that you're interested to make, and then play with the software to determine the layout of your peptides on the membrane. I use the command .neoline to skip to the next line, and you can also use it twice to have an empty row between your peptide sets. Then once you have the sequence in it, it will use it to calculate exactly how much of each reagent you need, which is very neat. So it will tell you exactly how much in milligrams of the amino acid you need and how much in milliliter of DMF you should add to it. But I highly recommend making at least twice the amount, because you don't want the needle to accidentally suck up any air during the synthesis. You want to make sure there is enough reagent there and there is a void volume always associated with these. So I made about twice as much for each, and you can also use the tool to adjust the amounts. I also recommend doing the peptide powder measurements a day in advance and then leave them in the freezer so it will not take time on the day of the experiment. Then you can take them out an hour to thaw and then add DMF to them, vortex them until they're fully dissolved, and this might take a while. So after they're dissolved, you transfer them to the pipette rack. Then you can turn on the instrument and the vacuum pump. You also have to make the other reagents according to the software, the 20% piperidine solution, that will be the deprotectant, the activator, HOBT, and the base, DIC, and the capping solution and everything. So I also made those and put them in their allocated spots. The membrane before the experiment has to be soaked in DMF for 20 minutes. Then you take off the frame of the instrument, put the membrane in a way that there is no wrinkles in it, and then it's flat. Then you put back the frame and then screw it on equally on each side. Then you want to rinse the needles and make sure they're rinsed and there are no air bubbles in the tubes. There is a DMF line and then there is an ethanol line. Make sure they're both rinsed, and then move the needle around to make sure there are nothing is obstructing its way and it moves smoothly. Make sure there is enough DMF and ethanol, and then once everything's loaded, basically start the experiment. You can do a vacuum pump of the DMF and then do an ethanol wash and another vacuum by yourself, and if you don't do it, it's okay because it's already in the method. So first it will just do some washing of the membrane, turn on the vacuum by itself until it's dry, and then do another ethanol wash and then do another vacuum pump. So this is the first wash that it will do on the membrane. Then it will start activating the amino acids that it needs by taking a little bit of each amino acid and taking it into the small tube that is beside it, and then adding a little bit of activator right before it, because the activator has to be mixed in exactly before that amino acid is needed. So it does that very efficiently and it will spot them on the membrane. Another thing that I forgot to mention before starting the experiment is that you want to make sure that the needle height is so that it touches the membrane gently, and it's not too high or low. You want to check the height on each corner of the membrane and also in the center. And also you want to do the same for the Z height of the needle. When it wants to add the piperidine, it has to be a bit higher than the membrane, and it should not touch it. Once the experiment is over, you can turn everything off, unscrew the frame, and gently mark one side of the membrane with a pencil and take everything off. And you want to wash the membrane with some water. Wash with water for 3 times, and each time should be 5 minutes, and let it just mutate. After that, you want to wash it 3 times, and each time 5 minutes with ethanol. And after that, you want to let it completely dry before adding the cleavage cocktail that would cleave the protected side chains. The cleavage cocktail contains 9.5 ml TFA, 300 microliter tips, and 200 microliters of water. And once you add that, you let it sit in it for 2 hours. Then you come back and you need to do more washes, 4 times 2 minutes with dichloromethane, then 4 times 2 minutes with DMF again, then 4 times 2 minutes with ethanol finally. And once you wash it with ethanol, it's always 95% ethanol, because once you use it, you want to let it dry afterwards. So after this, you let it completely air dry again for an hour, and then you make 0.1% fast green solution in 95% ethanol and cover the membrane completely with fast green solution and let the membrane get stained for 5 minutes. And once you do that, you will be able to see that the stain will bind the positively charged residue, so the spots where synthesis occurred will get stained. And this is a sign that everything worked well. And then you want to get rid of some of the background stain, and you do that by washing the membrane with methanol and then some PBS. And then finally you can see how well you can see that the spots got stained, but in different ways because their charges are different. Finally, cover in plastic and foil and keep in freezer.